Okay, so we are still class in the elements has a group 1A. Ano nga? Ano other name ng group 1A? How should we call them?
Alkaline, ma'am. Alkaline.
Okay, very good. Alkali metals. They are all metals except hydrogen. So let's have the third element. We have the sodium here. Again, sodium comes from the word natrium, which means nature. And what else? What else do we need to know about sodium? It's the most abundant extracellular cation. I'm not sure if I have already told you about this last time, but we use this mnemonics for us to easily remember the elements inside and outside the cell and which of them are the most abundant. Sige. So a little review. We have here magnesium and potassium in, meaning they are inside the cell. We call that intracellular. So supposedly they are inside the cell. However, among the two, potassium is the most abundant. Okay? Lithium. Okay. Sige. Again, we have magnesium and potassium. These two are the most abundant intracellular cation. When you say intracellular, inside the cell. Pero mas madami si potassium, second lang si magnesium. And then sodium, the S there is the sodium, and K is, okay, K is calcium. So ito naman sila are outside. Sige. So when you say outside, we call that extracellular. And then take note ha, cation kasi these are all positively charged ions. Okay? Now, the most abundant among the two is the sodium. Second, si calcium. But it doesn't mean na sila lang dalawa yung ion na makikita natin outside the cell. Marami pang iba. It's just that silang dalawa yung pinaka marami. Okay? So, we can remember that using our mnemonics, magpiso ka. Okay? Wala lang. Sige. Now, aside from that, class, sodium is responsible for fluid retention. What do I mean by this? If you have here your blood vessel and then you consume a lot of sodium in your diet, ikaw itong mahilig magparat, mahilig ka kumain ng mga salty food, ang mangyayari dyan, from your gastrointestinal tract, sodium will travel and will be transferred in your blood. Okay? Now, si sodium kasi is considered a solute. Remember, if you have a solution, we have two components. We have the solute and the solvent. The solute is the one being dissolved and most of the time is present at smaller amount, while solvent naman is used to dissolve. Okay? And again, most of the time present in larger amount. Now, our universal solvent is most of the time water, no? Pero marami pa tayong solvent. However, in the body class, ganito yung mangyayari. Since sodium is considered a solute, this will exert an osmotic action in the body. Okay? Magkakaroon ng osmosis. Sige, ano nga meaning ng osmosis natin? Ano nga meaning nun? Ha?
Movement of solvent mo.
Okay, very good. This one involves the movement of solvent. And since our universal solvent is water, so most likely this is referring to water. So saan siya mag-move? Movement of solvent from a region of lower to higher solute concentration. So, ayan yun. This is the movement of solvent from a region of lower to higher solute concentration. Now, ang mangyayari in the body, in your blood, you will have a lot of sodium. And then, since marami dyang sodium compared sa other part or sa outside niyan, mangyayari susunod si water. Okay? So, susunod si water dito. Kasi nga again, yung blood natin is a region of higher solute concentration. Now, what will happen? This will mean there is increased volume of our blood. Dadami yung blood natin kasi nga sumunod yung water dyan sa blood vessel. And because dumami yung volume ng ating blood, na ano yan siya class, nagre-require din yan siya ng mataas na force for it to flow. And when you say force needed for the blood to flow, we are referring to the blood pressure. So what does it mean? If you have increased volume of blood, you will also have increased blood pressure. Okay? And at the same time, it will be difficult for us to excrete the fluid in the body because sodium will keep water inside. Hindi ka basta-basta makaka-excrete, hindi ka basta-basta maiihi ng fluid mo. So, mangyayari, magtapok na tanan ang water in the body. And that will result, aside from hypertension, kasi diba, increased blood pressure means hypertension. Mangyayari, if you have fluid retention, mag-remain ang water, ang fluid inside the body, you may have this condition called edema. Okay? What does it mean? Anong ibig sabihin ng edema? Ibig sabihin ng edema?
Ang pupong, ma'am.
Yeah, manghupong, magmanas, meaning there is accumulation of water in the body. So, depende na yon sa ang part siya mag-accumulate. It may be in the feet, it may be in the hands, or even in the face, pwede din, as long as the water cannot be excreted and it will just remain in the body. Yes. Sino yun?
Ano yun siya, ma'am? Accumulation
of water in the body. Yes, Artea.
Ma'am, excuse ma'am, may na-mention ka po last meeting ma'am ba yung edema magmanas po yun ma'am? Ano po yun? Kani ma'am?
Pagmanas sa Tagalog, we call that manas. Sa Bisaya, we call that hupong. Yun. Pero that's the same.
Ayaw po ma'am.
That's the same thing, ha? There is accumulation of water. I don't know if you saw someone na merong heart condition, merong heart failure. Most of them kasi experiences water retention. Yung kanilang paa lumalaki. And if you're going to hold that part na nagmanas or naghupong, very soft, and malalaman mo talaga that there is water inside. Okay? So yan yung sinasabing edema. That happens when you are unable to excrete the fluid or water from your body. Nag-accumulate. Yeah, sa mga dialysis patient, they may experience edema also since 'di ba they have problems sa kanilang kidneys. Medyo nahihirapan silang umihi, and because of that, water will stay in the body and will be accumulated in the tissues, okay, in the different parts of the body. So mag-edema sila. But that's another case, no, kasi they have problem with the heart, they have problem with the kidneys. Ito kasi sodium will just really cause retention of fluid inside the body. So it is very important for us to limit, okay, the sodium intake. Let's limit our sodium intake, class. Get rid of the too much sodium na mga pagkaon sa inyong hangganan, no? Or if you want to eat that, please do so in moderation. Okay? Now, aside from that, sodium is our cation of choice to optimize the pharmaceutical utility of organic medicaments. So sabi ko, I think last time sa inyo, there are drugs class na merong sodium, meron ngang potassium sa kanilang salt. So example, diclofenac sodium. So, mapapansin niyo ito sa butika class, may mga drugs talaga na ganito yung kanyang generic name. Or if we are going to spell out this one, that's diclofenac sodium. So, sodium is used to complete the drug and at the same time, make it a salt. Kasi kapag salt kasi siya yung form ng drug, madali siyang ma-dissolve in the body. Class, if the drug is taken orally, it is very important for it to be dissolved inside. Kasi if hindi siya nadi-dissolve in the body, hindi mo yan siya maa-absorb. Mangyayari dyan, ininom mo siyang tablet, i-excrete mo siyang tablet. Ganun yung mangyayari. If hindi siya nadi-dissolve. So for us to optimize the solubility of the drug, most of the time we are combining the drug and another metal, and most of the time it's sodium. Okay, ito yung ibig sabihin ng cation of choice to optimize the pharmaceutical utility of organic medicaments. Yeah, pag masubraan, makahupong. Okay, so do you have questions or clarifications here? Before we'll move on to the different compounds of sodium kasi masyadong marami siyang compounds class. Nagtanaw ko sa ako ang PPT, daghan jud kayo mag-memorize on. Yes, Atasha. Ngayon. Yes, send mo lang yung question mo ha. This will be the compounds of sodium. So what do you need to remember here? Syempre the name and then the horizon. The name of the compound, the chemical formula, and then the uses. Okay? So sometime I also incorporate this one, the chemical structure. This is the chemical formula here. Itong wait lang. NaCH3COO, and this is the chemical structure.
Opa. Oh, nagkaon na ka?
Ikaw na mo. Ayan, if bakit masakit pag i-touch po. It will be really painful because remember, supposedly the water class in the body is being distributed and used, no? Ang problema kasi dyan, nag-accumulate siya in one part of the body. And in that part, we have their pain receptors, we have neurons na ano siya, maiipit kasi siya with the water that gets accumulated. So if you're going to touch pa that, samot ang kasakitan na, no? Kasi supposedly wala sila dyan. Anywhere in our body class, we have pain receptors. And if naiipit yung pain receptors na yan or nasa-stretch yan because of, example, injury, because of things that get stuck there like water or fluid, talagang automatic masakit yan. Okay? Yes? What else?
Excuse, ma'am. Ma'am, iba lagi ang ma'am, ang partner sa mga elements good ma'am dra sa structure kaysa sa formula.
What do you mean partner?
Pareha gud sa ma'am kanang sodium acetate like H3C tapos ONA lagi na ma'am.
Yeah.
O tapos sodium.
This is really the structure of the sodium acetate. CH3. Ito kasi, when you say kasi chemical formula, ano yan siya, this is parang summary of all the elements found in the compound. So, hindi talaga siya yung tamang pagkasunod-sunod ng elements class in the correct structure. Okay? So, ito yun siya. Ang talagang sodium acetate, it contains CH3. Actually, meron kang C dyan. You will learn this one in your organic chemistry. Kasi this one is organic. Then you have C double bond O and then another O here, and O is connected to the sodium. Okay, this is again the correct structure. If we are going to elucidate the structure of the compound, we have a lot of ways to elucidate the structure. Makikita talaga natin na ito yung arrangement nila. Okay, so the chemical structure is actually the correct one when it comes to the arrangement of the elements in a compound. Ito kasi talagang summary lang ito. Summary of all the elements na nasa compound mo. Okay? Pero we have to arrange it since this involves ions, charges, we have to arrange it na nauna yung positively charged sa negatively charged. So kung isusulat din natin yung chemical formula, ito pa rin yung tama. Hindi nga lang ito yung pagkakasunod-sunod pagdating sa chemical structure. So ito yung medyo mahirap sa chemistry, no, kasi you have to remember the chemical formula, but at the same time you have to remember the chemical structure also. If you're going to ask me, meron bang lumalabas sa board exam nito? Yeah, meron. Pero most of the time, it's on the drugs mismo. Like during our time, I think there were two structures na lumabas sa board exam namin. I cannot remember the other one, but I remembered penicillin. Lumabas yun siya sa board exam namin. Like ang sa question, nag-draw sila ng structure. So may structure sa question. Tapos yung choices, letter A, it's penicillin. Letter B, cephalosporin. Letter C, I forgot the other choices though. But I'm really sure after the exam na tama akong answer kasi I know the structure of penicillin. So yan, kasali pa din yan siya sa board exam natin. Kasi meron tayong tinatawag na SAR, Structure Activity Relationship, wherein we really study the structure of the drug, I mean the chemical structure of the drug, kasi dyan mo makikita yung action nila sa body. Okay? So ito, medyo ito, very simple structures kasi this is just one compound. Okay? But you need to know that also kung paano na-arrange yung elements sa compound natin. Okay? Now, let's start with the compounds of our sodium. Let's have the first one, the sodium acetate. Anong gamit ng sodium acetate natin? Number one, pwede siyang gamitin as a diuretic. What do you mean by diuretic? Ba ibig sabihin ng diuretic? Anyone who knows what?
Ma'am.
Okay, very good. Pampaihi. Okay, pampaihi. Diuretics are used to increase volume of urine. So we have a lot of diuretics in the market. We just don't have the sodium acetate, no? We don't really have a single drug that contains sodium acetate. We have a lot of diuretics in the market, but those are like complicated drugs now when we look at the structure. So one example of that is furosemide. I just don't know if you are familiar with that, but for those who have family members with hypertension or with heart failure, you may see one or two diuretics in the drug of that someone na kakilala ninyo. So again, example is furosemide or kaya spironolactone. Ito yung mga names ng ating mga diuretics that are available. Recorded? Yeah, recorded. Okay? Now, again, sodium acetate is used as a diuretic. But at the same time, this is called a urinary alkalizer. What do you mean by that? Alkalizer means we are going to make the urine basic or alkaline. Okay? Gagawin nating basic or alkaline yung ihi using the sodium acetate. Kailan natin ginagawa yon? Bakit natin ginagawang basic or alkaline yung ihi ng isang tao? Ito yon ang reason. Pwedeng because of poisoning or toxicity of acidic substances. Okay. So example ha, accidentally nagkaroon ng poisoning sa not really accidentally or deliberately nagkaroon ng poisoning, example sa ascorbic acid, our vitamin C. Like ni-choose talaga ng isang person na laklakin yung vitamin C, no? So remember, vitamin C is an acidic substance. When you have kasi poisoning sa acidic or sa basic substance, hindi natin pinapasuka yung ating patient. Ba yan yung mostly ginagawa natin pag merong poisoning, pinapasuka. Pero sa mga acidic na mga substance and basic na substance, hindi natin ginagawa yon. Kasi kapag ipapasuka natin sila, that is called butcha, double kill. Kasi example, kung hindi vitamin C ha, tahay accidentally nakainom ang person ng hydrochloric acid like sa laboratory. Pag nainom niya yan, syempre these acids are corrosive. They can cause injury sa mga tissues natin. Pag pass through ng acid na yan sa ating gastrointestinal tract, coming from the mouth to the esophagus and so on, nasusunog yung mga parts na nadaanan nun. Na kung ipapasukan mo pa yung patient, double kill na yon kasi binabalik mo. Nasunog na nga siya, binalik mo pa, kay pinasukan mo yung patient mo, nasunog na ta siya, nasunog na dyan sa mot. So, butcha ang tawag, ana. Okay? Double sunog. So, ang ginagawa natin? Ginagawa nating alkaline yung ihi. In the case, Hana, there is poisoning of acidic substances. Ginagawa natin, again, basic ang ihi. Bakit? This one is, nasabi ko ito sa inyo, yung number 1 question sa board exam namin. But you have an acidic substance. So you have an acid. And then, kapag ginawa mo basic yung urine, so you have the acid plus a base. Ano nga yung ating products nito? Kapag nagkaroon sila ng interaction. Again, ano nga products?
Salt, ma'am. Sure.
Okay, very good. You have the salt here and at the same time, water. Okay? So, ano connect nun, ma'am? Bakit kailangan mag-interact si acid and si base? Remember, class, si salt. I'm not talking about sodium chloride here, ha? Any salt. Okay? It's possible here. Salt is a combination of a positively and a negatively charged substance. Now, kapag meron ka kasing salt, pag naging salt kasi ang isang substance, madali mo din siyang maiihi. Okay? Kasi salts are always pero not all salts, though most of the salts, class, are soluble in water. And remember, our urine is made up of water. So, madi-dissolve yan siya doon. And since ma-dissolve siya, madali siyang ma-excrete. So, that's the rationale why in toxicity or poisoning of acidic substances, we alkalinize the urine. Okay? Again, para madali siyang ma-excrete kapag naging salt na siya. Kailan siya magiging salt? If the acidic substance interacts with a substance na basic or alkaline. So in that case, the urine will be alkalinized, and yan yung magre-react sa acidic substance na nainom, like the vitamin C, ascorbic acid, and so on. Marami pa tayong masyadong drugs na acidic. Okay? Or marami tayong substances na considered acidic. Okay? Questions? Wala. So sodium acetate is basic substance ha. If we're going to check its pH, automatically we'll see that it is really a basic substance. And in that reason, aside sa ginagamit siya as a urinary alkalizer, it is also, this is not actually alkalizer, alkalinizer. Okay? Aside from that, pwede din siyang gamitin as antacid. Sige, what do you mean by antacid? Antacid means?
Preventing ano po, acidity.
Okay.
Anti-acid.
So this is actually a shortcut for anti-acid. Okay? So people class with hyperacidity or with GERD. GERD is gastroesophageal reflux disease. We abbreviate this as GERD, or in layman's term, this is what we call heartburn. Okay? It is when the too much acid in the stomach will go up sa esophagus, going up, no, nagre-reflux siya sa dami ng acid sa tiyan mo. And because dumaan siya sa esophagus, feeling mo masakit yung heart. Kaya tinawag siyang heartburn. But it's not really, it's not the heart na may problema, but yung acid lang na na nag-reflux. Okay? So, antacid din ang ating sodium acetate. Pero we don't really use this one in our practice. No, we have a lot of antacids in the market, like Kreml S, though Kreml S is a brand name, pero iba kasi yung kanyang generic, yung kanyang content. It contains aluminum hydroxide and magnesium hydroxide. Hangin yon kapag ka nagbe-burp ka, hangin yon. Hangin ang lumalabas. Gaya lang yan kapag ka umutot ka. Okay? Hyperacidity is different. Masakit sa tiyan ang hyperacidity and marami kang pwedeng ma-experience na masakit sa katawan mo. Masakit ang tiyan, tapos pag nagre-reflux ka kasi, masakit yung yung chest mo, and kapag lumabas talaga yan siya dito sa mouth, lain ang acid class, lain dyan ang lasa sa acid. Yes, Artea.
Excuse ma'am, ang mother na ko ma'am may hyperacidity good ma'am. Kanang ma'am, kanang normal na nang murag maano good ma'am. No, tanan ako. Kanang ma'am, kanang murag makuyapan good ma'am.
Yeah. If you have hyperacidity, since I also have hyperacidity, it's normal. You may experience shortness sa breath, mahirap huminga. Basta basta marami ka masyadong acid. And at the same time, lain kay siya sa ulo, pwede magsakit ang imuhang ulo. Ya kanang feeling nimo nagalutaw imuhang ulo. Aside sa sakit ng imuhang tiyan, what else? Mahirap huminga. And some also experiences palpitation kapag ka nag-hyperacidity sila. So, kaya yan yung reason na hindi ako nagpapagutom. And at the same time, as much as possible, let's get away with acidic foods and yung, oily foods. Kasi oil, remember, contains fatty acids. And ayun, nagkakos din yan siya ng hyperacidity. Okay? Char. Pero yung mga healthy foods kasi, yan yung mga food na hindi talaga kaaya-aya sa ating panglasa. Yung mga masasarap na food, hindi din sila most of the time healthy kasi. Okay? Sige. So we have here sodium bicarbonate. Other name for our sodium bicarbonate is the baking soda. This is really the baking soda that we use for baking. Now, aside from that, since that is the industrial use, how about the pharmaceutical use of sodium bicarbonate? We have here systemic antacid. So just like sodium acetate, ginagamit din itong antacid. In fact, meron talaga tayong drug in the market, a tablet in the market that is called sodium bicarb. Okay, sodium bicarbonate na tablet. And we dispense this drug for those things, hyperacidity, ulcer, or GERD. Okay, and aside from that, this is also used as a carbonating agent. When you say carbonating agent, syempre it contains carbon and it will release carbon dioxide. Okay, I'll explain that one later as we move on kasi we have a discussion about carbonating agents later. Now, what's our problem with using the sodium bicarbonate, okay, as antacid most of the time, no? It can cause systemic alkalosis, meaning as you administer or take a lot of sodium bicarb, it will affect the pH of your blood. So, syempre, di ba, basic substance siya and it may go to your blood. So, again, it may cause systemic alkalosis. It will increase the pH. Remember, our normal pH is 7.35 to 7.45. Now, if it is more than 7.45, alkalosis na yung tawag natin. Now, in that case, our organs, our macromolecules in the body, just like our proteins, will not function efficiently. So magkakaroon yan siya ng corresponding effect in the body, and at worst, it may cause death kapag hindi naagapan yung systemic alkalosis. Okay? And be careful of using the sodium bicarbonate for hyperacidity kasi it can cause rebound hyperacidity. What do you mean by this? Yung kasi, sodium bicarb, kaya hindi talaga siya sikat na doon. Dinidispense din natin yan siya for hyperacidity. Pero compared to Kreml S, Imeco, mga brand names yan sila lahat ha, masikat yun sila. And ito, hindi masyadong ginagamit. That is because of the rebound hyperacidity class. When you say rebound hyperacidity, prolonged use of sodium bicarb, when I say prolonged, more than 1 week ka nang umiinom ng sodium bicarb, ang mangyayari, when you stop drinking the sodium bicarb, nagre-rebound yung hyperacidity. You are treated already ha, hindi ka na nag-hyperacidity kasi nga umiinom ka ng sodium bicarb. But after that, after the prolonged use of this, babalik yung hyperacidity mo, magre-release ng maraming acid yung tiyan mo, and it is more than yung amount niya is more than the original hyperacidity that you had.
Doble siya, ma'am.
Yeah, mas doble siya. Yung sakit doble, yung lahat ng may experience mo doble din. So that's why we call it rebound hyperacidity. Therefore, class, ang indication ng sodium bicarb is just to use this for a short period of time. It may be 3 days or at most 5 days. Okay? Eh, babalik yan siya and mas malala yung hyperacidity na mangyayari. Okay? I hope that is clear. Now, if you are going to work in the pharmacy and someone wants to buy the sodium bicarb, you really have to inform that patient na hindi siya ginagamit for a long period of time. Okay? And aside from that, please take note, sodium bicarb is used as an antidote for zinc poisoning. Okay? Pag example lang ha, there is an accidental poisoning sa zinc or deliberate poisoning, kung siya mismo nag-intake ng substance na marami masyadong zinc, ang ginagawa nating antidote is si sodium bicarb. Okay, anyway, you have a separate subject for poisons ha. Meron talaga tayong subject for poisons. Now remember, according to Paracelsus, the difference between a drug and a poison is the dose. So drugs can also be called poison if i-increase natin ang dose more than the yung kanyang effective dose niya. Abutin natin yung toxic dose. So kaya meron again din tayong subject na magdi-discuss kayo ng poison and ano yung gagawin kapag na-poison ka ng substance na yan. So you will have this one example, zinc poisoning. Though i-touch lang natin siya very konti lang, you will have the deeper discussions of toxicology. So that is our subject. Yan yung pangalan ng subject, toxicology. Okay, questions or clarifications? Yes, Arthea.
Ma'am, sa katugong, ano ko yung question, ma'am, katong sodium bicarbonate, good, ma'am? Ang maximum niya, ma'am, nga dapat ina-intake, 5 days lang, ma'am.
Yeah. Actually, pwedeng 1 week, 1 full week, 7 days, pero beyond that, wag na siyang sumobra para hindi mag-rebound hyperacidity. Especially kapag ka naka 2 weeks ka na, no, adlaw-adlaw giinom nimo ang sodium bicarb. Nga, pagka human-an na, rebound hyperacidity na dayon. Okay? So do not use it for a long period of time. Maintenance. That is not a maintenance drug. Okay, let's move on. We have the sodium dihydrogen phosphate, or our NH2PO4. So if you are going to look at the structure, it looks like this. Okay, again, NaH2PO4, sodium dihydrogen phosphate. Now, in the market, we call this fleet enema. Ito talaga yung brand name niya, fleet enema. Okay, bakit? Anong gamit yan? Pag sinabing enema class, ano yun siya, ginagamit as a laxative or a cathartic. Cathartic is a drastic na pagbawas na mauubos talaga lahat ng laman ng inyong intestines. Okay? Lalabas nyo talaga yan. Now, ano yung mukha ng fleet edema na yan? Let me see if...
Or siya douche, ma'am.
Yeah, wait lang. Let us show everyone. Ano yan siya? Nakabote yan siya. Nung ano yung fleet enema.
Bote siya, tapos parang may parang tube sa taas, na ano.
This one, like this. I hope you can see it in the screen. So, ganito yung mukha ng fleet enema. And, ang gagawin mo dito, papasok mo to sa anus mo. Tapos, uubusin mo yung laman yan. Papasok natin sa anus natin, ha? And then, after some time, class, makrot dyan ng sulod sa inyong intestine. Okay, when do we do that? Kailan natin to ginagamit? Siyempre, for those who have severe constipation, di makabawas. At the same time, those persons who will undergo like colonoscopy or endoscopy, ba may ipapasok na parang camera inside to examine what is happening in the gastrointestinal tract. Siyempre, hindi mo naman makikita yan kapag may mga tae sa loob. Kaya nililinisan muna. Okay, papalabasin muna. Kaya yung mga mag-undergo ng surgery involving the intestinal tract, the gastrointestinal tract, pwede silang mag-fleet enema. And then, again, there is a cathartic action here. Malalabas lahat yung dapat ilabas. Walang matitira. Okay? Questions? Or clarifications? Now, if you combine the sodium dihydrogen phosphate with the methenamine, this is used as a urinary acidifier. Baliktad ito ha sa sodium acetate. Si sodium acetate is urinary alkalinizer. Gawing basic yung ating urine. This time naman, gagawing acidic. Okay, wait lang ha. Now, itong methenamine kasi, ano kasi, patsingon kiko, wait lang. Struggle of having rhinitis. Basta, buntag. Pangatsing. Anyway, sige, again, si methenamine class, ganito yon. Methionine is an antibiotic na ginagamit natin most of the time for UTI. Okay? Pag iniinom kasi natin ito, si methionine will produce formaldehyde. Ito yung kanyang active metabolite. When you say active metabolite, this is the one that causes the action, the antibacterial action. See? Formaldehyde. And formaldehyde is acidic in nature. And that is the reason why magiging siya. Ganito kasi. Wait lang ha. Draw natin. Wait lang. Wait. Sige. So, si methionine, gusto na ko isulat. Hindi. Alam. Oy. Nan kay arte sa life. Si methionine kasi magiging, yan siya, magiging formaldehyde lang siya kapag ang pH is 5. Okay? Now, syempre, hindi naman talaga 5 yung pH ng ating urine always. So, kailangan natin i-acidify muna yung urine. Okay? And how do we do that? We are going to combine the methionine with the sodium dihydrogen phosphate. So, in that case, naging 5 na yung pH and that's the time mare-release si formaldehyde. And si formaldehyde na yung magkakos ng antibacterial action. Okay? Because again, methionine is considered antibiotic. Si sodium dihydrogen phosphate is not an antibiotic ha. Ginagamit lang natin yan siya as cathartic. Pero kapag sa methionine, urinary, yan siya, acidifier. Okay? Questions or clarifications? May tingog akong cellphone. Wala?
Ma'am.
Sige.
Wala
Now,
po.
we have the sodium bisulfite, or we call this sodium metabisulfite. This is naman used as a water-soluble antioxidant. Ito ba trabaho ng antioxidant? This is the structure ha, NaSH. May O pa yan siya. Binalagay dyan. Anyway, that's sodium bisulfate. Again, ano ba meaning ng antioxidant? Hulaton dyan ako ninyong hang
Ano siya ma'am, kanang substansya nga protect sa cells against free radicals.
Okay, very good. Again, antioxidant class are substances that protect our cells from free radicals. Okay? Yung mga na yan, free radicals. They are called free radical scavengers, by the way, ang antioxidant. Yung free radicals kasi most of the time it's oxygen. Most of the time oxygen yan siya. Pero diba, you know that oxygen class is positive. Positive 2 tuloy. Negative 2. Negative 2. Diba yan yung charge talaga ni oxygen. Pero, ang problema, inside the body, may mga oxygen na nabubuo na hindi tama yung charge. Minsan, they are negative 1. Ito yung tinatawag na free radicals and meron silang negative effects sa cells natin. So, anong kino-cause nito? Presence of these free radicals can cause the signs of aging. Ano ba signs ng aging natin? Hindi nag-chat. You have the wrinkles, you have the eye bags. Class, kapag ka nagapulaw mo, instead of this oxygen na tama ang charge, nagre-release yung body natin, nabubuo class sa body natin yung maraming negative 1 na oxygen. Kaya pagising mo sa umaga, mura na kag black panda. Bilog na naka-dark circles. Yan yung cause. And you have also the wrinkles and other signs of aging. But aside from the signs of aging, free radicals can also cause diseases like cancer. They can cause mutation sa mga cells natin sa ating DNA. So again, nagkukos yan sila ng sakit. So, what do we do in our body? We have antioxidants class to counteract the activity of these free radicals. Antioxidant means they will inhibit the oxidation of these substances. Okay, nag-o-oxidize kasi yan siya from -2 to mataas, nagiging -1. Remember, mas mataas yung -1 in terms of value compared sa -2. So, pipigilan natin yung oxidation kasi oxidation is reason of the release of these free radicals. And at the same time, kung sa mga drugs or sa mga products natin sa market, yung oxidation din is the #1 reason of the destruction, yung pagka-destroy ng ating mga pharmaceuticals. Okay, presence of oxygen will cause oxidation. And then again, that would mean destruction for our products. So anong ginagawa natin kung sa body, we also consume antioxidant in the form of vitamin C. Vitamin C is an antioxidant, ascorbic acid. But its action as an antioxidant is more on the immune system. Okay? Para iwas sakit. Kasi nga sabi ko kanina, these free radicals can cause diseases. And at the same time, we have antioxidant in the form of vitamin E. Okay? So kaya kung nakikita niyo, if you have observed yung advertisement ng vitamin E is pampaguwapa. That is to counteract the effects of the free radicals sa aging ha. Now, sa mga pharmaceuticals natin, if we look at our drugs or our cosmetics or even our food product class, sometimes contain antioxidant. Hindi nga lang siya naka-label dyan na antioxidant, but if you're going to analyze all the ingredients dyan sa mga products natin, merong isa or dalawa dyan na considered as antioxidant. And that is to prevent degradation of our product. Okay? Now, isa dyan, si sodium bisulfite. If you're going to see products class, yung ingredient nila, if makikita niyo si sodium bisulfite or metabisulfite dyan, isa lang ang meaning yan. Antioxidant yon. But this case, kasi water-soluble antioxidant siya. So, sa mga products na yung base is water. Okay? Ang value ang magbabago. Nagiging -1 siya instead of negative. Okay? So to avoid these free radicals na ma-form in the body, you sleep early, you eat healthy. Kasi yung mga food din na kinakain natin, yung tinatawag, kaya nga sila tinatawag na unhealthy foods. Kasi ito yung isang reason. Magre-release sila ng maraming antioxidant in the body. And that is not good. Sa ipansit kanton. Nagdagan ng MSG. Okay, questions about this one before tayo mag-move on sa other compounds pa ng ating sodium? Na? So we have here the sodium carbonate. It's different ha. This one here is the sodium bicarbonate. It's NaHCO3. And then this one naman is Na2 CO3. We call this sodium carbonate. But just like sodium bicarb, sodium carbonate is also used as an antacid. Okay? Antacid, anti-acid. And at the same time, a carbonating agent. Again, when you say carbonating agent, it's a source of carbon dioxide. And most of the time, it's used for palatability purposes. When you say palatability, pampalami sa lasa, just like sa Coke. Okay? Carbon dioxide is the reason for the sparkling taste sa Coke. Now, aside from that, sodium carbonate is used as alkalinizing agent in Benedict's solution. You will, class, encounter Benedict's solution kapag ka magbabiochem na kayo. You will encounter this one, Benedict's solution. Benedict's solution contains copper sulfate and at the same time, dinadagdagan din siya ng sodium carbonate. But the sole reason of the sodium carbonate is to make the solution alkaline or basic. But ang question, saan ba natin ginagamit si Benedict's solution? Benedict's test, class, uses Benedict's solution to differentiate reducing and non-reducing sugar. Kapag sa biochem, pag magdi-discuss na kayo ng carbohydrates, kasi yan naman yung dinidiscuss sa biochem, di ba? Chemical substances na nasa body natin. Okay? Mga macromolecules na nasa body. So, isa dyan yung carbohydrate. And we classify our carbohydrates or our sugar whether they are reducing or non-reducing. And to check kung reducing ba siya or non-reducing, yan yung ginagamit natin, si Benedict's solution. Anyway, you'll encounter that one sa biochem ninyo. Now, we have different types of sodium carbonate. Actually, this is dependent to the presence of water molecule in their crystal lattice. Kasi example, naka-crystal ito, no? Yung one molecule of sodium carbonate is connected to molecules of water. Tapos, meron na namang sodium carbonate na crystal, na molecule, and then nagbubuo sila ng crystal. Okay, so, kapag walang water molecule doon sa crystal ng ating sodium carbonate, yan yung tinatawag na anhydrous soda ash. Okay? Anhydrous kasi walang H2O. Okay? Soda ash. Ang tawag natin kay sodium carbonate. Now, if meron siyang two molecules of water in its crystal lattice, we call that trona. And then, pag 10 talaga na water molecule doon sa crystal niya, we call that washing soda or soda crystals or sal soda. So, basic pangutan ko ninyo, kailangan dyan naman i-memorize nun, ma'am. Yes, you really need to memorize this. Especially that the current board exam is, ang nakakoncentrate sila dito sa farm in org. Marami daw itong lumabas. So you need to know the names of these compounds also. Labi na paggamito nato sila to make drugs or to make pharmaceuticals. Iba-iba kasi sila. The presence of water, though it's still sodium carbonate, magkakaroon ng difference yan in the physical and most of, meron ding sa chemical properties of these compounds. Okay? So again, you need to know their names also. Now, let's talk about effervescent preparations. Dito tayo magto-talk about doon sa carbonating agents. Do you know what effervescent preparation is? Or do you have any knowledge on this? Ano ba meaning ng effervescent preparation? Actually, I believe you know this very well. It's just that some of you might not know kung ano yung effervescent na preparation. Pero baka may alam kayo anything about effervescent preparation. Muta na tabi. Ang mga naghilom-hilom din ha. Basig natulog na na.
Pardon, ma'am.
What do you mean by effervescent preparation? Hindi yun siya product. The solution will just be called Benedict's solution. You will have copper sulfate and then lagyan mo siya ng sodium carbonate. Sodium carbonate will just act as an alkalinizer na substance para maging basic or alkaline yung solution. But the main ingredient of the Benedict's solution is copper sulfate. Yes.
Na-pension ni sa among pharmacist ana siya kay ang karang effervescent amot lang kung connected with ako siya karang mga effervescent tablets is karang murag gina-compress gud niya ang mga active ingredients with sa mixture sa sodium bicarb tama ba ma'am tapos with organic acids.
Yeah. Tapos, kato lang.
Wato siya ma'am tapos katong mga tapos na po tong ingiingon niya nga karang murag mag-release siya carbon dioxide, basta ka na patuloy ba siya mo?
Yeah, very good. When you say effervescent preparations class, ito yung either tablet or powder na pag nilalagay niyo sa tubig nagabula-bula. Nakatry na mo pag-inom. Tablet ha or powder. Nilagay niyo sa tubig nagbula-bula siya.
Yes, ma'am. Katong ano yata, ma'am, sa ganito na. Bata po na, ma'am, nakatry ibutang sa tubig, ma'am, bago i-imnon.
Yeah. Beroka is one. I don't know if you have taken Beroka. Pero Beroka kasi is a vitamin C plus other minerals. Tapos we also have Fluimucil, ng tambal sa ubo. Pero brand name ng Fluimucil ha, the generic name is acetylcysteine. Brand name na siya. Again, acetylcysteine ang generic, brand name ang Fluimucil. Tong tambal sa ubo class na i-powder ani, tapos naapoy tablet, tong dako nga tablet class, tapos tinutunaw siya sa water before mo siya inumin. Okay? Kung na-hospital ka, tapos inuubo ka ha, especially if merong phlegm. Yeah, the tablet is 600 milligrams. Yung powder is 100 and 200. Dalawang klase yun siya. And then what else? Yung mga effervescent preparations natin. Ano pa ba? Hydrate. I don't know if hydrate is an effervescent preparation. Anyway, when you say effervescent preparation, it's a combination of basic substance and then organic acid. Aside from the active ingredient ha. Ang active ingredient, that's the ingredient in your preparation that will cause class the effect or the pharmacological action. Pero pag effervescent lang, ito lang yun. Basic substance, pwede siya carbonate or bicarbonate. So, pwede siya sodium carbonate or sodium bicarbonate. Tapos, hahalo natin siya sa organic acid. So, it might be tartaric acid, citric acid, malic acid, or even ascorbic acid. Pag nilagay mo kasi ito sa water, yung action ng water doon din sa acid and sa base will produce carbon dioxide. So kaya mo na siya pagbutang nimo sa tubig nagabula-bula, it signifies the release of the carbon dioxide. And if carbon dioxide is released, ano yan siya, nagiging yung sa panglasa natin, for palatability purposes talaga ito, na mas masarap yung lasa ng iniinom mo na gamot. Okay? So yan yung reason bakit gumagawa tayo ng effervescent preparation. Okay? Nasabtan? Pero dili na siya mao ang active ingredient ha. Ito lang yung basic and acidic substances na nilalagay natin sa effervescent preparation. Questions? Yes, Lauren?
Ano yun siya, ma'am? Combination of basic substance and organic, ma'am? Inorganic.
Organic. These are organic acids. Ang inorganic acids natin, yung mga hydrochloric acid, sulfuric acid, nitric acid, hindi yun sila kasali dito. Mga organic acids, ito sila. Now, most of our effervescent preparations contain carbonate or bicarbonate bicarbonate ha. Tapos ang acid mostly na nilalagay nila combination of tartaric acid, dalawa. The other one is citric acid. Yan yung mostly na preparation natin sa mga effervescents. Okay? Bakit hinahalo si tartaric acid at si citric acid? Kasi kapag ka tartaric acid lang class, sulat ko siya ha. Kapag kasi tartaric acid lang kasi, carbonate plus or bicarbonate tapos tartaric acid lang, ang mafo-form mo na preparation or even your tablet is easily magka-crumble. Okay? Madali siyang masira yung tablet. Hindi talaga siya nabubuo. Na kailangan kasi 'di ba tablet ma-form talaga 'yan. Pag dinispense mo siya sa butika, talagang buong tablet siya. No, kapag yung tartaric acid lang yung ginamit mo, madaling mag-crumble yung tablet mo. Tapos kung citric acid din lang naman ang ilalagay natin, the powder here to form the tablet will be very sticky. So, hindi natin gusto yung mga conditions na ito. Now, to avoid this, i-combine na lang natin silang dalawa, tartaric acid and citric acid. They will counteract the effect of each other. So, maging yan siya, tama-tama lang yung pagiging sticky niya and at the same time, hindi siya madaling mag-crumble. So, that is the reason again why we combine tartaric acid and citric acid. Okay? So, nung estudyante ako, for me to remember this easily, ang iniisip ko na lang kapag ka na-tartar imuhang ngipon, dali na siya maguba. So, easily mag-crumble na siya. And then citric acid, iniisip ko na lang din na when it comes to like citrus, 'di ba? Citric acid is found in our citrus fruits like calamansi, 'di ba? Pag nilagay mo siya sa skin mo, sticky siya. Yan yung iniisip ko para hindi ko siya makalimutan. Okay? Lagkit. Yeah. Okay, questions? Before tayo mag-move on.
None, ma'am.
Wala. Okay, sa time na. Hindi pa time. Still have time, no? Sige nga, no, di naman na-move akong slide. Ayan na. Okay, now let's talk about sodium chloride. Sodium chloride is best known as our rock salt or our table salt. But we also call this solar salt. So, anong gamit nito? Siyempre, industrially, we use this as a condiment para sa panglasa, no? Sa atuang pagkaon. But, sa ating mga products, may it be pharmaceutical or food product, ginagamit siya as a preservative. So nakita nyo yung yung fina-ferment, 'di ba, yung mga ginamos, ang bulad, inabutangan nila og asin. And that is the reason to preserve those food. Kaya even ang itlog. Now sa pharmaceutical na side, we use the sodium chloride as an electrolyte replenisher. Okay? So like in the case class na you have diarrhea or meron kang sakit that causes depletion of sodium and chloride inside the body, syempre bibigyan ka ng replenisher para ma-replenish kung ano yung kulang. Okay? So that will be in the form of fluid replacement therapy or yung IV natin. So hindi natin siya pwedeng tawaging dextrose ha kasi hindi dextrose yung kanyang laman. Kasi pag na-hospital tayo, pangutan-un din tagi dextrose ka, na dextrose na siya, pero pag tanawon na to ang gikabit sa iyahan na IV fluid, dili di ay dextrose. Especially the green one, sodium chloride is color green. So, pagtanaw na to ay sodium chloride, banda ang gihatag sa patients. So, hindi yun siya dextrose ha. Most of the time, it's 0.9% sodium chloride solution. Or this is what we call the PNSS or the plain normal saline solution. Yan yung binibigay. Electrolyte replenisher. Labi na basta ginalagnat pud ka class, kasi magkakaroon ng electrolyte imbalance yan. Pag masyadong mataas yung temperature mo. Okay? So, pwedeng bigyan ng PNSS. Plain normal saline solution. Okay? Questions? Or clarifications with that? Let us add some more activity of our sodium chloride. Ginagamit din ito as during iodism. Iodism is the condition na masyado ka maraming iodine in the body. So pwedeng nagkaroon ng accidental or deliberate na poisoning or nagkaroon ka ng toxicity. Si sodium chloride class is used to rapidly eliminate iodine in the body. Okay, that's one use of our sodium chloride. Now, aside sa PNSS class, again, PNSS is colored green ha, green yan siya, yung lalagyan ng IV fluid, yung kanyang label is colored green. Now, meron din tayong green ang label. Meron din tayong color blue ang label. It's buya. Meron din tayong tinatawag na Ringer's solution. Pero si Ringer's solution is a combination of sodium chloride, potassium chloride, and calcium chloride. So parang mas marami siyang mas marami siya na electrolyte na content. Kasi pag PNSS, as in plain lang talaga na water and at the same time the 0.9% sodium chloride. Si Ringer's solution, tatlo. Sodium chloride, potassium chloride, and calcium chloride. But you don't call this dextrose also kasi wala yan siyang dextrose na content. Malalaman nyo naman yun, class, if pumunta kayo ng hospital, you look at the IV fluid, pag nakalagay dextrose 5% in water, o kaya dextrose 10% in water, pwede ding D5LR, dextrose 5% in lactated Ringer's solution. Yan yung dextrose. Yan yung dextrose. Pero kung Ringer's solution lang, sodium chloride lang yun, potassium and calcium chloride, wala itong dextrose. The dark blue is the Ringer's solution. And then yung sky blue, I think, is the lactated Ringer's solution. Meron din tayong tinatawag na lactated Ringer's solution. Tingnan nyo talaga kung ano yung binibigay sa inyo na fluid ha. Pag lactated Ringer's solution, it still contains the sodium chloride, potassium chloride, calcium chloride, pero may dagdag siya na sodium lactate. Okay? Nag-overlap. Anyway, that's sodium lactate. We call that lactated Ringer's solution. So, iba-iba sila ng gamit sa hospital. Depende yun siya sa need ng patient. Kung meron siyang need na specific na electrolyte that needs to be replenished, yun yung ibibigay sa kanya na IV fluid. If the person needs energy, kasi like hindi siya makakakain talaga, yan yung time na bibigyan tayo ng dextrose. Dextrose is the other name of glucose. And remember, glucose is our physiological sugar. And dyan tayo kumukuha ng energy. Okay? Questions? Or tayo mag-sodium citrate? Tapos pag after sa sodium citrate, let's have our break, water break and CR break. Wala. Sure.
Wala na po,
Ma'am,
ma'am.
unsa tong blue, ma'am?
Blue, the the Ringer's solution, it's the dark blue. Tapos,
Thank you po, ma'am.
sky blue ang lactated Ringer's solution. Tama ba? Hindi na ako na sila memorize class dugay na kay kuha ka itong hospital. I'm sure lang ko.
Ma'am, ang green, ma'am, gato ng PNSS, ma'am.
Oo. Okay, check ko. Para tama talaga. No. The blue one, the dark blue pala is the lactated ringer solution. Palihog ko cambio. Again, the dark blue is the lactated ringers solution. Tapos, let's see the ringer solution color na to. What is the color? Wait lang class. Let's check. Baliktad eh. It's the sky blue is the ringer solution. Yeah, the sky blue is the ringer solution. And then the green one is the sodium chloride, the PNSS. Is it baliktad? Oh, depende sa brand. Wala silang blue. Excuse me. Okay. Daw? Pwede ako paulit sa sodium chloride. Anong part doon ang ulitin natin? Alin doon? Anyway, this is being recorded ha. If you missed something, you just look at the recording again. I'll upload this sa YouTube. Hindi ko lang siya pinopost yung link talaga sa sa School UG. Pero hanapin niyo lang siya sa YouTube. Nandun yun siya naka-folder. Naka-isang playlist lahat ng sa Farm in Org. Okay, so we have sodium citrate. This is sodium citrate ha. Tatlong sodium, C6H5O7. So in this case, this is actually an organic substance. You have carbon here. Na nang gamit ng ating sodium citrate due to the presence of the citrate, it's not because of the sodium ha. The citrate there class is considered anticoagulant. Okay? Ano ba ibig sabihin ng anticoagulant? Pag binigyan ka ng drug and ang nakalagay anticoagulant, nung ibig sabihin nun?
Effect po sa blood, ma'am.
Yeah. Anong part dun sa blood? Okay, very good. Prevents clotting of blood. Kapag na-injured ka, tapos there is bleeding, kailangan talaga mag-clot ang blood para hindi maubos yung dugo mo. Pero, may mga cases din na hindi natin gusto mag-clot ang dugo. So, we will be preventing clotting. Okay? Sige. So, anti-coagulant yung tawag doon. Okay? Like in the case of people with hypertension or with heart failure, may mga conditions sa cardiovascular system, binibigyan natin sila ng anticoagulant. Okay? Kasi kapag nag-clot yung dugo nila inside, pwedeng kung sa brain yun siya, pwedeng mauwi yun siya sa stroke. So yun yung reason ha bakit may stroke. There is clot formation in a part sa brain, and because merong clot, hindi makaka-flow yung blood. So makukulangan class ng oxygen yung brain mo kasi hindi na nakapass through because naging obstruction si clot doon. Yan yung stroke. Okay? So merong mga, depende kasi siya kung saang part siya ng brain, nagkaroon ng clotting, anong part ng brain yung naapektuhan. Kaya iba-iba din yung nagiging effect ng stroke. Kung nagsusurvive yung patient ha, kasi may iba talaga na hindi sila nakakasurvive, namamatay talaga. Pag nakasurvive, merong iba na nahihirapan ng magsalita, merong iba na napaparalyze. So depende yun siya sa part ng brain na naapektuhan, na nakulangan ng oxygen. Okay? Na kung sa, ano naman yon, kung sa heart yon, yung clot formation, yung heart muscles naman yung nade-deplete ng oxygen kasi hindi na nakapass through yung dugo, yan yung pwedeng mag-experience ang patient ng myocardial infarction, or we call that in layman's term, heart attack. Okay, yan yung tinatawag na heart attack. So if you are going to observe in the pharmacy, those people with hypertension or cardiovascular disorders are given anticoagulant. Okay? Para hindi mag-clot ang dugo. Okay? Prevent clotting. Yeah, prevent clotting. Tranexamic acid is baliktad. Tranexamic acid will make your blood clot. So, I don't know if you have experienced taking tranexamic acid, like kapag ka nagpapabunot ka ng ngipin class, aside sa the doctor will give you, example, antibiotic to prevent infection, the doctor will also give you tranexamic acid para mag-clot dayon imuhang dugo di na mahurot. Para mag-clot dayon na dili magsigig bleeding tong part class na na binunutan ng ngipin. So baliktad si tranexamic acid. So in this case, sodium citrate, because of the presence of the citrate, will make it anticoagulant and at the same time diuretic. Ginagamit din siyang diuretic and it can also cause chronic acidosis. So baliktad din ito sa previous natin na diniscuss na compound. This will cause lowering of the pH of the blood. Again, mag-acidosis. Pero actually, parehas lang sila na if you have acidosis, your macromolecules, your tissues and organs will not function efficiently. And at the same time, buffer. Tapos na tayo sa buffer, right? Buffer class are buffers or any substance that resist changes in pH. Okay? Kung ilalagay natin si sodium citrate doon sa mga pharmaceutical or other products natin, cosmetics, food products, magiging buffer siya. Para if ever there are changes in the pH, like may addition of either acidic or basic substance, hindi basta-bastang nag-change yung pH. Okay? And pwede din siyang alkalinizer actually. Depende sa gamit niya doon sa, depende din ito sa combine niya na compound. And then, at the same time, expectorant. So, ano ba ibig sabihin ng expectorant? This is to expel phlegm. Okay? Now, side effect of this sodium citrate, since this is anticoagulant class, if ever you have injuries, pwede kang mag-bleeding or at worst, pwedeng mag-hemorrhage. Pwede din maubos yung dugo mo kasi nga hindi na nagka-clot yung iyong dugo. Okay? That is for the sodium citrate. Okay? By the way, in the laboratory, nagtetest tayo for us to determine and differentiate citrate from tartrate. Ang ginagawa natin na test is the Denige test. I don't know how to pronounce this correctly, but nevertheless, tama ito ang spelling. Yan yung test, again, to differentiate citrate and tartrate. Ang content nitong solution ng Denige test is 3:1. 3:1 ratio of 3:1 ratio of pyridine. So, 3% na pyridine, tapos one portion of that will be acetic anhydride. Yan yung content ng solution, ha. Pero for us to determine and differentiate tartrate from citrate, pag i-conduct natin ito na test, tapos ang nakuha natin is carmine red, ito yung color ng solution, this signifies the presence of the citrate. Pero pag ang nakuha natin during the test is emerald green, this signifies the presence of the tartrate. Okay? Additional information, baka lang itanong sa inyo, like sa board exam. Okay? So sabi ko, let's take a break. A little break lang, CR break. We have here sodium fluoride class. Ginagamit ito as anti-cardiogenic agent at 2% concentration. What do you mean by anti-cardiogenic agent? Anti-caries para di madaling masira yung inyong ngipin. Okay? Now, for dentrifices, when you say, class, dentrifices, ito yung mga ginagamit natin pang polish sa ngipin. Meron ding sodium fluoride yan, pero at 1.1% only. Pero ganun pa rin yung gamit niya, anti-cariogenic, to prevent formation of caries or prevent tooth decay. Okay? However, we don't really use fluoride, no? Fluoride in general at large amount, especially to children. Kasi at large amount class, nakakasira din siya actually ng ngipin. So as you can see, konti lang talaga, 2% or 1.1%. Okay? So, merong mga toothpaste, especially sa mga bata, na wala talaga silang fluoride ion. So just like the product named as Sun's Flu, wala yan siyang fluoride ion. Kasi again, kung sa bata, madaling masira yung kanilang ngipin kapag it has too much fluorine. Okay? Kasi fluorine is very corrosive and at the same time toxic. Toxic din yan siya kapag nasobrahan ka ng fluorine, pwede yan siya mag-cause ng burn. Example, sa bibig or even sa skin natin, it causes painful na very slow healing na burns. Matagal pa talaga dugay siya maayo, okay? So, kapag siya, ginamit natin siyang anti-cariogenic agent, yung kanyang activity is magpa-prevent yan siya ng protein synthesis sa bacteria para hindi sila dumami. Okay? Pwede din yan siyang mag-cause ng lysis ng bacterial cell membrane. So example, this is the bacterial cell. Bacterial cell is lined by a cell membrane to keep the components of the cell intact. Na kapag there is the presence of fluoride ion na class, na-tear up itong cell membrane na ito, and whatever is inside, like yung mga organelles, sa cytoplasm, lalabas yan siya. And that means cell death. That's how it prevents proliferation of bacteria sa bibig natin and para hindi or ma-prevent natin yung tooth decay. Okay? So, kailangan din natin ng fluorine sa mga ngipin natin ha kasi pag nasa ngipin na kasi yan siya, it will form fluoroapatite. Yan yung magfo-form yan siya ng fluoroapatite sa ngipin natin, which is a solid na crystal. So, pwedeng mag-polish sa ngipin and at the same time, it will make our teeth hard para hindi siya again madaling masira. Kasi pag walang fluoroapatite, yung naglaline sa ngipin natin is just hydroxyapatite. So, compared sa fluoroapatite, mas smooth and at the same time, ang tawag dyan, madaling masira itong hydroxyapatite na ito. Okay? Then yung gamit ng ating sodium fluoride. So if you look at our toothpaste, meron yan siyang konting fluoride. Pwedeng in the form of sodium fluoride. Iba din yung nilalagay ng dentist na fluoride lain kay glasa. Like kay glasa nga fluoride, no? Pwede din yun siya actually sodium fluoride lang. Pero ganun pa rin naman yung gamit niya, anti-cariogenic to prevent tooth decay. Okay? Ang problema kapag nasobrahan ka naman, sigira kagbutang sa imuhang ngipon o fluoride, it may cause dental fluorosis. So itong dental fluorosis is also known as mottled enamel. Let's look at Google kung ano ang mukha ng mottled enamel na ito. Para alam nyo kung need nyo pa ba na maraming fluorine sa ngipin ninyo. Magiging ganito ang ngipin ninyo class pag masyadong maraming fluorine. So this is like the normal teeth, no? This has the mild mottled enamel or dental fluorosis. There will be discoloration. Ito moderate. Ito talaga severe na dental fluorosis. So especially in children, kapag masyadong maraming fluorine ang ginagamit. Kasi nga sabi ko, fluorine is toxic also. We just need that in small amount to prevent the decay of our teeth. Pero pag nasobrahan, masusunog din kasi siya. So that will cause discoloration. Again, we call this dental fluorosis or the mottled enamel. That's the side effect of too much fluorine. Too much fluorine na usage. Okay? Questions or clarifications sa sodium fluoride before tayo mag-move on sa kay sodium hydroxide? Wala. Now, how about sodium hydroxide class? The sodium hydroxide or NaOH is also known as caustic soda, lye soda, sosa, or liquid sosa, or lye. Yung ginagamit natin na sabi mo palit atong parent of sosa or lye soda. Ito yon, sodium hydroxide yun siya. Na ginagamit nila, example, nagbara ang CR ninyo or nagbara yung inyong lababo. Yun yung ginagamit nila, the liquid sosa. Okay? Matutunaw kasi yung whatever is nabara doon. That's how strong sodium hydroxide is. So, nakalagay dyan, diba? Strong base and it's caustic. And especially if magkaroon ng contact with our skin, there will be rapid destruction sa cells natin. Talagang matutunaw yung ating cells. But sa laboratory, we use sodium hydroxide as a saponifying agent to produce hard soap. Ang ginagamit natin ngayon, pangligo natin na soap, na yung mga hard soap talaga ha, like yung Safeguard, yung Palmolive, they are actually made up of sodium hydroxide. That's the action of sodium hydroxide to a fat or an oil. Yan lang naman yung ginagamit natin pag gumawa tayo ng soap. Either you use fats ba ng baka yan, or yung baboy, or oil, like olive oil, ganon. Tapos lalagyan mo siya ng sodium hydroxide, titigas yan siya. And yun na yung magiging soap natin. So I don't know with you if you have experienced soap making in your high school days, but sa pharma, yes, tuturuan kayong gumawa ng soap. Okay? Using again the sodium hydroxide. And we use this one also in titrimetry. We have the so-called titration. Ginagamit natin yan siya for drug assay. Like, if we want to know the concentration of a substance, nagtatitrate tayo sa laboratory through the use of the burette. And then yan yung mag-change ang color, and then stop na yung iyong titration, and pwede ka nang mag-compute ng iyong concentration. So for example, sa vinegar, if we want to know, meron tayong experiment sa laboratory checking the percentage or the concentration of the acetic acid in vinegar. So pinagawa ko yun sa mga students ko last time. I asked them to bring different brands of vinegar, including tuba and the vinegar that can be bought sa public market, yung naka-cellophane lang. And then we tested the concentration of the acetic acid. So, syempre, yung mga well-known vinegars natin sa market, they passed. Kasi meron lang yung parang requirement or standard kung gaano lang karami dapat yung acetic acid na nasa vinegar natin. So, yung mga dato puti, yung mga silver swan, syempre, nakakapasa yan siya sa testing. That is through titration ha. We will do that in the laboratory also. Pinapareact natin, example, yung vinegar sa sodium hydroxide, and then after the reaction we can compute kasi tinitingnan lang natin yung volume ng sodium hydroxide na nako-consume during the reaction, tapos pwede na natin i-compute yung percentage. That's the use of titrimetry. Kaya lang yung hindi nakapasa during our experiment yung tingi-tingi na binibili sa public market na naka-cellophane lang. Masyadong mataas yung yung kanilang acetic acid na content. Please take note ha, sodium hydroxide is very corrosive. In fact, since this is a base, it can cause liquefactive necrosis. Ito yung sinasabi kong natutunaw talaga. Adto ni sa imong mata, matunaw imong mata. Okay? And at the same time, naka-pellets kasi ito. Aside from the solution, meron tayong sodium hydroxide pellets nito. And even the solution, they are considered deliquescent. Ano ang ibig sabihin ng deliquescent? Ito yung mga substances class na absorbs water from air. Di ba may water naman talaga yung air natin, especially in the Philippines. We are very humid here. Yung sodium hydroxide mismo, ina-absorb niya yung water na nasa air natin, and then after that, magli-liquefy siya. So from solid substance, nagiging liquid siya. And at the same time, sodium hydroxide class undergoes leaching. When you say leaching, ina-attack nito, attacks the container, especially the glass one. Attacks the glass container, and ang mangyayari, yung component ng glass, nasisira yung glass, yung component ng glass, parang natutunaw, napupunta doon sa sodium hydroxide. And then yung sodium hydroxide mo, hindi na siya pure. Magiging contaminated na siya from the substances na nag-degrade galing doon sa glass mo. Kaya as much as possible, we don't place the sodium hydroxide in a glass container. So ano yan siya? Most likely sa plastic container yan siya. Kasi ang ina-attack niya yung silicone na nasa glass. Okay? Magiging silicon hydroxide siya. Yung silicon, magiging silicon hydroxide kapag inattack na siya ng ating sodium hydroxide. Okay? So yan yung mga dapat niyong tandaan sa sodium hydroxide. But aside from that pala, the sodium hydroxide test solution, TS is test solution, ginagamit natin ito as a reagent or a test to differentiate mercurous from mercuric salt. So, di ba, ginagamit natin yung mga names na yan to differentiate the charges. Kung lower charge, the positive one is called mercurous, the mercuric is the positive 2. Now, to differentiate that, we use the sodium hydroxide. Magkaiba sila ng results sa testing. Okay?